In this video, we're going to be walking through my oil report for 11,000 miles. We've done about 4 tests now, including a test on the Amsoil out of the bottle. So I know some folks in the last video were looking at that saying, hey, why is there kind of a 0 miles number? That was to establish a baseline. So we've tested up at about 1,000-mile increments. And today we have Lake Speed Jr. with us again to walk through this report. So without further ado, here's Lake.
Hey, Harry, this is awesome. This is fun. I'm so glad that you have invited us to come along with your journey here to see how do you extend that drain interval. How do you make your vehicle, one, have the reliability you want, but number two, have the lowest cost of maintenance and convenience because you do a lot of miles. So there's a lot of reasons for you to extend the drain interval if you can safely. And I really think from looking at this trend analysis, I suspect there's some pretty interesting nuggets for everybody that they're going to want to stay tuned and watch all of these things, because there's probably a few things that you're going to learn that you've never heard of before. So here's the report that from your last one. Like you said, that one in the far right-hand column is the new oil right out of the bottle.
Yep.
And then we've got 3 samples at basically 9,000, 10,000, and 11,000 miles. And what we see from, top down, viscosity is the most important characteristic of a lubricant. So we start off with viscosity first in terms of the results.
Right.
Oil health. It's a 5W40, so 13.3 centistokes. That's right in the middle of that SAE viscosity grade. So it's not shearing, it's not breaking down, which is great, because anything between 12.5 and 16.3 centistokes, that's the SAE 40 grade range. So oils in viscosity, oxidation value actually decreased slightly from the previous sample. And we'll get there in a little bit, because I know you've moved. And I think the fact that you don't live in the same state anymore, there's going to be an interesting little thing we need to unpack here in a minute, but I don't want to get too far ahead of ourselves on that.
Right.
But then the fuel dilution did go up. So that's not great, but it's not the worst news ever, because this is a power stroke, and power strokes just have higher fuel dilution than other diesel engines, to the point where I should probably actually set a different level for what fuel dilution is for power strokes compared to, say, a Cummins or even a Duramax. They just tend to be a couple of percentage points lower in terms of fuel dilution.
And didn't you say that last time in our video? You said the power stroke is like an oil manufacturing machine. It just loves to make
one of them. It's not yours. Yours isn't special. They all do it. And yours is actually really good. We normally see even higher than this. It's not uncommon to see fuel dilution in the 5 to 8% range.
Wow.
Yeah. With way less miles than yours.
Interesting.
Yeah. Yeah. Of course, water, glycol, everything's negative there. Potassium is positive, but it's dropping. Again, there's a reason for that related to the fuel. And we'll hold off for a second. We can run through everything else really quick. If you look at the additive package, the calcium, the sodium, magnesium, phosphorus, zinc, molybdenum, boron, everything is stable, which is really good, because usually what will happen when you get really close to the end of the life of the oil, and that might be someone's question, right? So at 11,000 miles, man, you're pushing it. No, you're not. This oil is completely healthy. There's no indication here that the oil is even remotely close to giving up or being compromised in any way. Because you'll normally see, when you get near that limit of the working life of the oil, you're going to see that phosphorus start to drop. You'll see some consumption really coming down. And it's 1130 compared to 12,000 or 1,200 on the other ones. That's not a big change. 100 parts per million isn't a big change. If this had come back at, say, 1080 or 1020, then I would say, okay, that's an early indication that the phosphorus is being consumed you're getting near the point where the wear rate would probably begin to increase.
So as the phosphorus continued to decrease, then you would see a corresponding increase in the wear rate per 1,000 miles.
Yeah, absolutely. Yeah. Because that's the whole idea, right? You want to keep extending the drain out as long as your oxidation is okay and your wear rate per 1,000 miles is stable. The early indications on are we reaching the limit of those things is one, the oxidation value is going to go up. And you can see that.
Right.
That's easy. The early warning on the wear rate is typically going to be the phosphorus consumption will come right before the wear rate increases. So it'll let you be able to say, oop, stop, don't go any further before you actually do go too far and increase wear slightly. But so speaking of that, why don't you go ahead and tell everybody what's happened in terms of where you live and how that maybe has had some influence on these numbers, because there's a story right there in those first two columns, the difference in oxidation and the difference in fuel dilution and the potassium. That's where this story gets really interesting compared to what we've talked about previously.
Yeah. So the story there is my wife and I were living in St. Louis, and we changed locations a lot because she's a travel nurse. And so we moved from St. Louis, Missouri back to New Hampshire. And a lot of states in the Midwest run biodiesel blends. They're required to run up to 20% biodiesel blends. And so what I think happened, and we'll see as we continue to test, is the biodiesel tends to be a bit rougher on the engine. Ford even says in their recommendations, these trucks can run biodiesel, but you need to change your oil more often. And, there are papers that I found that I can link to in the description, research papers that basically document how your post-combustion treatment, the DPF and the EGR, specifically the DPF, have to work a lot harder because biodiesel creates more soot. And,
Right.
I think depending on what you get, it can be better for your fuel pump because biodiesel has more lubricity, but it doesn't burn as clean, period, end of story. And so that is what I think we're seeing, which is crazy because, you're seeing the oxidation value go down, but with 1,000 more miles on the oil, which is totally counterintuitive to what you would think.
And that's because of that biodiesel. Like you said, the bio constituent in the fuel is less oxidatively stable. It provides more lubricity for the fuel pumps. That's a bonus.
Right.
But like in the video that I put out recently about making motor oil, I actually showed that, just because you have some of the added lubricity doesn't mean that it's oxidatively stable. It could actually be less stable. And that's exactly what you're seeing here, is that bio-derived product, they tend to be really good in terms of adding lubricity, but they are not oxidatively stable. That's their weakness. And that's the reason why your oxidation value went down despite a longer drain interval, is because now you're not getting all that bio buildup. So the reality is, using New Hampshire fuel, non-bio-based fuel, you can probably push this even further than if you lived in the Midwest still and you were in that farming area where there's bio everything, right?
Yeah.
All the fuels are bio in the Midwest,
Yeah, which is a tough place to be if you live there and, you have one of these trucks. I mean, I guess it's good to know, but, it's like on the one hand, you have the mandate for these pollution control devices. And on the other hand, states are mandating, certain states are mandating, like, we're going to run biodiesel. So I think it's good to be aware of, because if you live in one of those states, then this is going to cause more stress on your DPF, and it's also going to stress your oil more. And so, if you're in one of those states, you gotta pay double attention.
No doubt about it. It's one of those things, like you said. Let's go back to the report here real quick. Biodiesel, there's some advantages in terms of lubricity, and there's certain parts of the country, like you said, where it's what they mandate. So you have to be aware of that. That if you're in that area, your oil change interval, the things you're doing are going to be different than if you live somewhere else. And like you said, that higher level of soot, because it doesn't burn as completely, is causing more regens. The increased number of regens is adding fuel dilution.
Right.
But the great news here is that the viscosity is not going down. So you're not seeing any negatives at that level, which is the reason why I kind of said earlier, we're going to reset those warning limits for this engine because those levels are not showing any negatives.
Right.
So there's no reason to say that it's bad just because in a book it says that that's bad. Right. It doesn't matter. That's what does the engine say? The engine's fine with it. We're not having a loss of viscosity. We're not seeing increased wear. So we can basically turn those off. Now, the other piece, you're using an additive in the fuel, right? That you're using the arch oil in the fuel.
Yeah.
That's where the potassium's coming from.
Yeah.
But you're not using it as much anymore, right? Not every time.
No, I'm still using it every fill up. That's interesting that it went down then, because I'm still doing it every tank, but I did decrease the dose. So actually that would make sense that the potassium's going down, because I did lower the dose to 1 ounce per 10 gallons instead of 2. So, okay.
Oh, there you go. That's perfect. And you can see that. And the other thing I was going to go with that is that when you lower that dosage rate, even if you stop using it, it's going to persist in the fuel system. That's one thing we see with fuel additives is that even though you maybe stopped using it, 5 tanks ago, there's still residue of that, residual still in the system that's still going to have effect. That's why you can use some of these cleaners. You can put them in and only use them once every 3,000 or 4,000 miles is because of this effect that it will stay around. So you cut the treat rate in half, you said, right? Since the last sample, but it's not half the number.
Right. Because that means some of it's still in the system. That's interesting.
Right.
Yeah. And that makes sense. So I went from running the Arch Oil 6500. I would do 2 ounces per 10 gallons every fill up, which is like kind of the max cetane boost, lubricity boost, that they advertise for the product. And, since the sample I did at 9,000 miles, I've kind of dropped it to 1 ounce per 10 gallons and been pretty consistent staying with that. So that would make sense. I did get a question on the last video on this particular point from a gentleman that was wondering what your thoughts were, because I think a lot of folks, they run them in the Power Strokes because they have the CP4 pump, and there's definitely a large fear that I also possess. That's, wanting to make sure that the CP4 is getting all the lubricity possible so that, it doesn't decide to blow itself up. So what would you say to that? I know like you're essentially saying, hey, you don't, because it stays in the system, you don't need to run it every fill up, but is there a benefit to protecting the fuel pump to run it every fill up?
Yes. The great thing about diesel fuel additives here in the US is that the diesel in the US does not contain additives. Right. And so because of things like the CP4 fuel pump, old school injectors that, the Pintle style ones that need lubricity, that's why the diesel oil fuel market is so big in terms of additives, because you're starting off with a, number 2 diesel that doesn't have an additive package in it, unlike the premium diesel that's available in Europe that does.
Right.
So you can really help the fuel. You can help the health of your engine by putting in an additive package that can bring it up. I did a video recently about, gasoline and the research on how premium gasoline, the higher octane gasoline isn't just higher octane. It also has a different and better additive package than the lower octane grades. And that better additive package actually reduces wear in the engine. So by using a diesel fuel additive, one that has lubricity to it, one that has detergents to keep the injectors clean, those kind of things, cetane improvement, all those things are really beneficial to helping the engine run better. And you can see that if you come back, we check this out, right? Before, when you were using the higher treat rate, you're at 126 ppm on the potassium, which in this case gives you a great marker. And now it's dropped down, but it took a couple of oil changes for it to actually get its way all the way down to about
Right.
half of where it was before. The reality is you still see that it's there. It's still doing something. And
Right.
just like we said, how oxidation isn't linear, the effect of most additives isn't linear. Typically,
Right.
you're going to get the most of the gain from the additive by putting in a small amount. And then it's incremental gains beyond that. So when you look at the wear rate on your engine, you're not seeing an increase in wear. So if you're not seeing an increase in wear on the cylinders, which that's your iron and chromium and things like that, you're not seeing an increase in wear on those parts. That means you're not going to get an increase in wear on the fuel pump as well.
Interesting. Okay. That makes sense, right? Because those are exposed to the same fuel that the fuel
That
pump
fuel
is.
is spraying on them, no different than the fuel's on that. And that's
Yeah, I never thought about that.
one of the
Yeah.
highest levels of wear in the whole engine is the piston ring against the cylinder wall. So when you see that overall wear in the engine is holding steady, that's a good way of judging what's happening there.
Interesting. That's really cool. Yeah. Yeah. So it sounds like you can in some way look at this report and also just be able to understand the environment that your fuel pump is operating under,
Yeah.
which is really interesting. That's really cool. The only other note I wanted to make was on the fuel dilution, it going up versus the 10,000 mile sample. So it kind of, it was up, it went down to 3.1, then back up to 4.3.
Yeah.
I did get a bad batch of fuel in Ohio, of all places. And I figured that was where I got it because I filled up after driving from Vermont all the way out to Ohio, got a full like 50 gallons of it. And as soon as I got back on the highway pulling out of the fill up station, the DPF percentage started to go up way faster. And it was incredible. And so it just kept going and going. And it was like, and then even when I was towing, so I went to the yard, picked up a load, turned around and was on I-80 doing 65, probably towing, nothing crazy, but like 8,000 pounds. And yeah, the thing just kept looping. And then eventually I got the code for regen frequency, which is P2459. And the regen frequency, it kept just burning and burning. It was doing it like every 100 miles. And then as soon as I got to Pennsylvania, filled up with non-biodiesel in Pennsylvania, pulled out of that station onto the highway, and the frequency immediately went back to like 350, 400 miles. It was unreal. I was like, this is incredible. So
you got the bottom of the tank in Ohio.
Yeah, I think I did. I don't think I have any other questions on this report, but I would like to bring up a few questions that we got on the last video, if that would be all right. The first one is with the fuel dilution, since we were talking about that. Mm-hmm. At what point and what value for a truck like this is it a no-go? Like when fuel dilution gets to X point, like you need to change your oil, or there's something wrong, like what in a power stroke is a value that would raise red flags?
Well, it's going to be a combination. So when I look at an oil analysis report, when I look at the data and I create the report, I should say, I'm looking holistically. I'm not letting only one value dictate the recommendation or the health of the report. What I'm looking at is a combination of factors. Like in your case, for example, the fuel dilution's 4% and it went up, right? That increase isn't good. But the reality is your viscosity is still in grade. Right. So it's not having a negative impact on the viscosity. And then it's not having a negative impact on wear. So if I see, iron and chromium and copper and tin and lead, if I see all those things increasing, then even if it was 4% or 5%, but if I saw the viscosity down and wear metals up, I'm going to say, hey, there's a problem here. that the fuel that you're getting in is actually causing a problem. That, different oils can handle fuel differently too. There's because you're talking about it's the gas chromatograph is reading the spectrum of molecules that are in the fuel. Fuel isn't a single molecule. Diesel's not one molecule. So, for example, you could have a fuel dilution that, let's say it's 5%, but it is, we'll call it raw fuel. It's the full spectrum. Well, that 5% is going to probably have a bigger impact on lowering viscosity, increasing wear than, 5% that's only the heavy ends of the fuel. That it's just the really heavy, longer, bigger molecules that they're not going to be as detrimental to everything else. And if that's, I know that's really kind of geeky science there, but raw fuel is going to be different than just what's the leftovers. I mean, think about a diesel pump. When you go to the pump, what's all that stuff on the ground? There's not at the gasoline, but there is the diesel. Well, that's not liquid diesel laying around. That's the heavy ends that don't evaporate off very easy.
Okay.
And think about what happens if you slept on it. It's slippery. It's not sticky, right? So it can, like in your case, let's pull it back up, right? That 4% is not hurting you. I'm not going to use only one number. If it came back next time at, say, 12,000 miles and it was, 5.5%, I'm not going to flag it next time as long as the viscosity is still in grade and the wear rate is still good.
Right. So it's interpreting.
Look at it.
Right. It's like interpreting. It sounds like you need to interpret the value in the context of the larger report.
Absolutely. That's it.
Yeah. Okay. Yeah. No, that makes a ton of sense. Cause if your wear rate's still good, and in this case went down and my fuel dilution went up, obviously the fuel dilution isn't impacting the engine's performance or wear. Yeah. So thank you. That's really interesting. The next
every part. I mean, that's for fuel dilution. That's looking at everything on the report has to be evaluated within the context of the entire data set and the application and the environment. And this, in your case, you have trend analysis, you have a history. So what does the history say? All of those things are way more important than a single value is by itself typically.
Right. Next question was, is there a case where oil might still be good, but the filter is reducing efficiency? Or essentially, in other words, how do you know if you're running these extended drain intervals, how do you know the filter is still good? Or put another way, when do you know in the report when the filter is no longer doing its job?
So the next level of analysis is adding particle counting.
Okay.
So that's the next thing. The standard kits we have do not include particle counting. Okay. But when you get there, if you're really going to try to push, and you could potentially push beyond the effectiveness or the efficiency of the filter,
right?
The particle count is going to tell you that.
Okay.
Because what you'll see is the particle counts should be pretty stable as long as you're not exceeding the capacity of the filter. And by capacity, I mean how much junk can the filter hold? Right. If it's just collecting stuff over time and it's pretty stable and it does that, then the total amount of stuff, particles in the oil, will be pretty stable. But if you reach the capacity and now it's bypassing more often because it's full, you'll see that particle count number shoot up, and then that's that way you can know. Okay.
All right. Yeah, that sounds like something I should look into and test just as we kind of get up there. It'd probably be good to know.
Yeah, if you get closer to that, at this point, I'm also looking at soot in the background, and that's one of the big indicators in a diesel is the soot. And as long as your soot's below 2%, then you don't even need to worry about that, right? Because that's the primary contaminant that's going to be causing the problems. And if the soot level's low, then your filter's not dirty.
Right, and the soot value is depicted in which value in the report? If you pull that back up again, that's the is that the silicon or is
No.
that the?
So that's in the background. So
Oh, okay.
we test for way more things than we put on the report.
Okay, got it.
Because if I put every single thing we tested, every single value on there, it's information overload.
Right.
So
Right,
what we
right,
try to do is kind of distill it down. So it's the things that are the most important. Now, if I saw something in one of those, we'll call it hidden values,
right.
that is a problem, I will actually notate it in the comment section.
Right. And I did see that you noted soot level was less than or about 0.5%.
Yeah. Yeah.
So yeah, obviously.
That's where I'll throw that in there if there's something that's outside. But yeah, we just for the sake of making it user friendly and not needing a PhD in organic chemistry to read one of these
Right.
things,
Right.
we throttle it back a little bit. This way it's not so overwhelming.
Yeah. No, that makes sense. Thank you. Yeah, those were just some of the questions I had saw in the comments, and thank you very much to the folks that commented them because they made me stop and think as well and just kind of wonder, it wasn't so much that I doubted the information in the report and that you potentially had the information. It was just, understanding better where all that was coming from. So
No, that's the whole point of doing all this stuff. That's why I love this, that I get energy from watching people learn. And, my goal isn't to tell everybody what oil to use and how
Right.
often to change their oil. My goal is to create content that enables people to figure it out for themselves, right? It's like they give a man a fish, teach him to fish. I want to teach them to fish.
Right.
I don't want to be the fish machine for oil.
Yeah.
It's just
Right.
going out all the time. I have no interest in that. I love to see questions like that. People, questioning things. Well, how does that work? That doesn't jive with what I've been told. Okay, great. And you got told wrong. So now let's fix it and get you on the right path.
Yeah.
So that when we have good understanding, you can make good decisions, which typically leads to good outcomes. And that's what we love to see.
Yeah. Well, I and the rest of the community appreciate what you're doing. And I've learned a tremendous amount, even just in our last 2 conversations. So it's definitely invaluable. And I actually just recently went to get my truck inspected, the state inspection. And the last time I was in there for an inspection, it had about 106,000 miles on it. And the other day I just rolled 184. So in a 12-month period, I did about 80,000 miles and it still runs great. I mean, I've had to, replace some sensors, but it just runs when I want. And I'm excited to keep it rolling and keep kind of the maintenance going. And for those of you interested in other aspects of it and maintenance, I am still planning to test my transmission oil, and I'm going to be testing my transfer case oil and probably the differential oil. Differential, I know, is a big one for truck guys. So,
you do so much towing, right? That one's going to be the one that will scare the crap out of you. By the way, when you see 200, 300 parts per million iron, you go, "Wah!" Yeah, but it's like,
I can't even imagine.
It's just normal.
Yeah. Man, yeah, I can only imagine because the stress that the diff is under is just,
and it's a non-filtered system. That's the thing about a differential is it's a non-filtered system. Even an automatic transmission, there's a giant filter in there.
Yeah, huge filter.
Yeah, and a rear end, like literally the best thing to do is like change your diff oil. Just change it because that's the only way to get the crap out.
Yeah. Yeah. There's no other way to get it out. Just you need to change it. Yeah.
No, just change it.
Yeah.
I know it stinks and it's not fun. I changed the diff oil in my dad's race car the other day. It ruined a set of clothes.
Yeah.
And I smelled to heaven. But it's what you got to do.
Yeah. It's the only way to get it done. Yeah. I've been doing every 50K on
that's really, really good. Yeah.
Yeah. I know that's what Ford recommends for heavy towing, but I mean, we'll see. I that's why I want to test it. Cause maybe I need to be doing it at like 20 or 30. I mean, it's a high, like you said, non-filtered, high stress part of the vehicle. So, we will see. But thank you, Lake, so much for coming on the channel again, and we will have more for you. I appreciate you, the viewer, following this series in oil testing. I'm fiddling with a few more things. We're eventually going to get a bypass filter. We're going to try some different oil filters. So be sure to subscribe to my channel, and I'll put a link below to Lake's channel and one of the videos he referenced on gasoline fuel quality. Very interesting. Check it out. As always, we appreciate you watching the videos, and we'll see you next time here on Power Stroke Maintenance. Cheers.